Another data representation method is the histogram and the frequency polygon. The two representation methods are related because a frequency polygon is obtained from a histogram. Histogram is used to represent continuous data. For group data with equal class intervals, upper class limits are plotted against the frequency to obtain a histogram. Let us look at an example. You're given the data on the table and you're required to represent this data on a histogram. So we have said we shall plot the upper class limits against the frequency, because if you look at the data, the class interval is equal. Now, given the classes, the midpoint between two classes is the class limit. So in this case, for the class 5 to 9 and 10 to 14, the midpoint is 9.5. The midpoint of the class 10 to 14, 15 to 19 is 14.5. The midpoint of the class 15 to 19, 20 to 24 is 19.5. And the upper class limit of the last class is 24.5. Here we have 4.5. So we use the class limits, the upper class limits on the x-axis and the frequency on the y-axis. And when we draw, we will obtain the figure alongside. So the bars, the continuous bars, represent the histogram. That is the histogram, the continuous bars. So the 4 bars, 1, 2, 3, 4, is the histogram for the data. The frequency polygon is obtained by joining the midpoints of the bars of the histogram. So we obtain midpoint, the midpoint of the bar, midpoint of the bar, the midpoint of the bar, the midpoint of the bar. So they are joined using a straight line, and the last midpoint in each case is joined to the x-axis at both ends to complete the polygon. Note that the midpoints must be joined to the x-axis for it to be called a polygon. because from the definition of a polygon is a many-sided figure. For grouped data with different class intervals, the histogram is drawn by plotting the upper class limits against the frequency density. And we calculate frequency density by dividing the frequency of the class over the class width. Consider the table below. In the table, we have the class 5 to 9, 10 to 19, 20 to 34, 35 to 39. And we have the frequencies for each class, 5, 8, 15, and 10. The frequency density will therefore be 5 over 5, because the class interval 5 to 9 has a class interval 5. The class 10 to 19 has a class interval of 10. The class 20 to 34 has a class interval of 15, and the class 35 to 39 has a class interval of 5. So this is a class 10 to 19, the class 20 to 34, and finally the class 35 to 39. So this gives us frequency density of 1, have 1 frequency density, 0.8, 1, and 2. So we plot the class limits, upper class limits, against the frequencies. Frequency density is as follows. So for the first one, for the first class, this is the class 4.5 to 9.5. Then from 9.5 to 19.5, 19.5 to 34.5, and finally 39.5. So the bars 1, 2, 3, 4 represent the histogram for the data alongside, while the midpoints of the bars, the midpoints of each of the bars are joined using a straight line and then eventually joined to the x-axis to complete the frequency polygon.